Hi, this is Manjeera Kalla and I am doing my Master's in Computer Science and Engineering at Texas A&M University, Kingsville. Today I would like to explain about the communicating sequential process, CSP. So, this is the course on type of current research for fall 2016 and my advisor, Dr. Engel. So what is CSP? Computer sequential process is a formal language for describing patterns of interaction in concurrent systems. It is a member of the family of mathematical theories of concurrency known as process algebras or process calculi based on message passing via channels. CSP was highly influential in the design of the Occam programming language and also influenced the design of programming languages such as Limbo and Go. So as its name suggests, CSP allows the description of systems in terms of component processes that operate independently. CSP was first described in a 1978 paper by Tony Hoare but has since evolved substantially. CSP has been practically applied in industry as a tool of specifying and verifying the concurrent aspects of a variety of different systems such as T9000 transparator. So the sequential part of CSP name is not something of a misnomer since modern CSP allows component process. That is the theory of CSP itself is also still the subject of active research, including work to increase its range of practically applicability. Example, increasing the scale of the system that can be tractably analyzed. So, and here it looks like as a parallel composition of more temporary process. So, what are the applications of CSP? So, if we go to the applications of CSP, it's like it's a well suited to modeling and analyzing systems and employed in verifying the correctness of both the process pipeline. And early and important application of CSP was its use for specification and verification of elements of INMOS T9000 transparator. CSP was employed in verifying the correctness of both the process pipeline and the virtual channel processing which managed off-chip communication for the process. So industrial application of CSP is software design has usually focused on dependable and safety critical systems. For example, Bremen Institute for Safe Systems and Daimler-Benz Aerospace modeled a fault management system. So CSP modeling and analysis during the development of software approximately is like 1 lakh lines of code for a secure smart card certification authority to verify that their designs are secure and free of deadlock. Since CSP is well suited to modeling and analyzing systems that incorporate complex message exchanging, it has also been applied to the verification of communication and security protocols. So they are like, it's divided, the CSP is divided into the notations and the primitives, and some of the CSP notations, they are, first one is, we will discuss about prefix. The prefix operators, it combines an event and a process to produce a new process. For example, here it shows the example like XB event and let BP process. So X tends to P, it's pronounced like X then P. So it's described like which first engages in the event X and then behaves exactly as described by P. So if you see like the notations here, the prefix is something which will be an event and a process to produce a new process. So the next one is, so here is the examples. And first example, if you see like a vending machine which consumes 1 coin before breaking. So we can donate it like it's coin before breaking. So coin then stop ABMS. So vending machine, we use 10 like 10 rule, so it's coin then stop ABMS. It denotes the same thing. And if you say in the second example, vending machine that successfully serves two customers before breaking. So it serves two customers, right? So if the coin, if this customer is willing to take the chocolate, so coin then chocolate, then it's also the whole thing was in the same thing, and we just give the sub things in the, and so coin gives the chocolate and it serves the two customers. So before breaking, it's then stop again. So next one, note. So note that the operator which gives the prefix, this operator also takes a process on the right and a single element on the left. So it means, say if you see P is P then Q, if P and Q are process, such a process could be correctly described. So it pronounces like incorrect one. So why it is? Because P and Q are process, so it cannot be denoted. So the P then Q, it can't be denoted. So it was the wrong. So such as process could be correctly described. So next one you can see P then Q, Q then stop. It's the correct one. So next one is the recursion. Recursion, many objects allow the behavior to be influenced by interaction with the environment within when they are placed. So by means of prefixing and recursion, it is possible to describe objects with a single possible string or behavior. So if you see, but it would be extremely tedious to write out the full behavior of vending machine for its maximum design. So we need this method. So recursion is used for this. So we can't see by using the prefix. So we use the recursion method. So for example, if you see in the recursion method, for example, a clock which never does anything but tick. So you know, right? A clock which never does anything but tick. It will not make anything but tick. So it's denoted by alpha, clock equal to tick. So it does anything but only tick. So it will be denoted by that. So the equation for the clock has some obvious consequence. So divided by simply substituting equal for equals. So the original equation is shown in the below. Tick is tick that clock. So by substitution, so we gave like alpha clock is equal to tick. So by the substitution, we get the same thing that's similar to the last equation. So the potential onboard behavior of the clock has been effectively defined as the same thing. Tick then tick, tick then tick, infinity. So it goes on like that. So the recursion, it denotes mu. So the symbol is the recursion is denoted. So it's like the repeating thing. So clock equal to mu x and tick. So this one is a recursion method. So the next notation we are discussing about is choice. However, many objects allow their behavior to be influenced by interaction with the environment within which they are placed. So if x and y are distinct events, so we denote the same thing. So P and Q are the process and x and y are the events. So x then P, y then Q, because the P and Q are the process and x and y are the events. So we separate them like this. So describes an object which initially engages in either of the event x or y. After the first event has occurred, the subsequent behavior of the object is described by P. So or by Q if the first event is y. This is the choice we are discussing. For example, a machine which offers a choice of two combinations of change for 5p. So if you see here, the choice 5p, the change for 5p. So we denote it like n. So the output 1p gives rise to, it tends to 5. So the choice will be the change for 5p. It offers a choice of two combinations, right? So we divided this separately, the two choices, and its change for 5p. So we can see in example 1, and the same thing with the example 2, a machine that serves either chocolate or toffee on each transaction. So we separated the x and y, the same thing that divides the events. So the chocolate and toffee, we divided it, the choice will be divided, and the chocolate and the toffee, we are separated different events. And here also the same example which denotes the choice. So see, in the last thing, like many complicated machines, this has a design flaw. There's a flaw. It is often easier to change the user manual than correct the design. So we write a notice on the machine. So the warning is, do not insert through machine 3 pennies in a row. Okay, next one is mutual recursion. So what is mutual recursion? For this to work properly, all the right hand sides must be guarded and each unknown process must appear exactly once on the left hand side of one of the equations. So recursion permits the definition of the single process as the solution of single equation. So the mutual recursion, it becomes like 2 functions are said to be mutual recursion if the first calls of the second, and in turn the second calls the first. So you can see from this. And for example, if you see here, a drinks dispenser has 2 buttons labeled orange and lemon. The action of pressing the 2 buttons are set on rage and settle now. The actions of dispensing a drink are orange and lemon. And here are the equations defining the alphabet behavior of the process DD. There are definition using 2 auxiliary definitions of O and L which are mutually recursive. So it denotes saturnine, settlement, orange and lemon. It says 2 buttons labeled orange and lemon. So the drink dispenser has only 2 buttons, so right? So orange, lemon, and the actions of dispensing drink are also the orange and lemon. So the choice of drink that will next be dispensed is made by pressing the corresponding button before any button is pressed. No drink will be dispensed. Here are the equations define the alphabet and behavior of the process DD. The definition uses 2 auxiliary definitions of O and L, which are mutually recursive. So if you see from the denotation below, you can understand how the mutual recursion is working out. So we came to CSP printers. CSP provides 2 classes of primitives in its process algebra, and its primitive process. If the process represents fundamental behaviors, examples include stop, the process that communicates nothing, also called deadlock, and skip, which represents successfully termination. So we denote the words in uppercase letters denote specific defined processes, example VMS. So if you see in the upper one, A, VMS, also VMS equal to, so the coin and chocolate, and we can have like different types of process. So next one is events. Events represent communication or interaction. They are asymmetrical, indivisible and instantaneous. They may be atomic names, example honor, compound names, example value. So if you see the examples, or input output. So events such as like if you take some of the examples like coin, chocolate, input P. In this case of simple vending machine, there are 2 kinds of events. So in this vending machine, we take 2 events. They are coin and chocolate, and the coin, which indicates the insertion of a coin in the slot of the vending machine, and the chocolate indicates the attraction of a chocolate from the dispenser of the machine. In case of more complex vending machines, there may be greater variety of events. So the attraction of like small or large biscuits. So if you take in case like a very long event. So next one is alphabet. Alphabet is considered the relevant for a particular description of an object is called its alphabet. The alphabet of process P is denoted alpha, the set of names of events which are considered relevant. Example, the same thing that happens with the events and the process, we take it differently, which denoted by alpha. So it may be called like alphabet. So we just completed the description of the communicating sequential process. So the reference I got is from Communicating Sequential Processing or Her June 21, 2004. It's a textbook and you can read from this. Thank you so much.